So the next speaker would be Joshua sorry, Grolua. I don't know if you are ready, Joshua.
Yeah, can you hear me?
We are like 10 minutes before what we, yeah, there you are.
All right, let me see if I can
So,
share my screen here.
Josh is the CEO of Pecos Wind, and he has experience in designing and manufacturing both megawatt and kilowatt size wind turbines. He is actually also being part of designing the US tallest concrete tower, and he has also worked with ducted wind turbines. And now we'll hear a little bit more about Pecos Wind and their activities. Welcome,
Yeah,
Josh.
thank you for the introduction. Thank you for the invite. Uh, Good morning and afternoon and probably evening for some folks. It's morning here, East Coast of the US. That's where we're based. Company name is Pecos Wind Power. I suppose we're probably the newest entrant to the medium scale wind market, or soon to be entrant to the market. We're developing an 85 kW horizontal axis wind turbine. We've been developing this machine for a few years now. We've had great support from a few governmental agencies in the US. We've been working closely with the National Renewable Energy Lab, Department of Energy, and Department of Defense in the US. So development's going pretty well, and just wanted to give you all an introduction to what we're doing. The machine's not yet commercially available. We're still testing the machine, but we're hoping that it'll be ready for commercial sales next year. So quick summary of the machine. As I mentioned, it's an 85 kW rated power. We've optimized power generation for low wind speeds. So in the US, we've got a pretty vast wind resource, but it's at a relatively low wind speed. So at our hub height, around 37 meters, we have lots of sites that are between 5 and 6 meters per second annual average, but we have very few sites that are greater than that. So we've optimized this machine for power generation for average wind speed sites between 5 and 6 meters per second. And we do that by using a relatively large rotor. So we have a 30-meter diameter rotor, which gives us a specific power ratio of about 120 watts per meter squared. So that's very low compared to other machines. We think that's the ticket to high capacity factors and low LCOE, low levelized cost of energy. This strategy worked for utility scale wind, and we think it'll be beneficial for smaller distributed scale turbines as well. Another approach we're taking with this machine is we're trying to leverage off-the-shelf components as much as possible. You know, we realize we're a small company. We're going to be probably producing relatively small volumes at the beginning. So how do we get decent economy of scale? Well, we can use off-the-shelf components. So we're using an off-the-shelf gearbox. We're using an off-the-shelf induction generator. As many off-the-shelf bearings and other components as possible to keep costs low. And also for serviceability, we think this is important. If we want to keep these machines running for a long time, we think there's benefit to having components that our customers can order out of a catalog if they have an issue with the machine. And then another kind of approach that we're taking to the development of this turbine is we've focused quite a bit on how we can minimize balance of plant cost. You know, for distributed wind projects like ours, the turbine itself is probably about half the cost of the project, and the other half of the cost is balance of plant. So we're talking transportation, installation, foundation, tower. So we're focused on how we can reduce these costs, and we've developed a pretty unique foundation that we think will allow us to deploy a turbine quite a bit faster. We've basically eliminated the cure time of concrete so that we can be in and out of a customer site, hopefully in a week. That's what we're targeting. So we actually just installed this foundation last week, and it was a pretty successful test run, and I've got a photo of what it looks like at the end here. So we're focused on grid-connected commercial electricity customers. So pretty typical market, from what I've been hearing throughout the presentations today. We're looking at farms, rural businesses, schools, municipalities. Initially, we're focused on the US just because that's where we're located. That's the market that we know the best. We're certainly interested in international markets, but we just want to prove out the machine, and we want to prove out our business model in the US first, and then expand internationally. Here's our power curve. I guess the important takeaway on this slide is that our capacity factors are pretty close to what you'd see for a utility scale machine. In 5 meters per second annual average, we're targeting a net capacity factor of low 30s. In 6 meters per second, we want to be over 40% capacity factor. And again, we do this by using such a large rotor. So as I mentioned, the machine is not yet ready. We are in the manufacturing and initial testing stages of our first turbine. What you see here, this is a photo that was taken just a few weeks ago in our contract manufacturing facility. This is our first machine. The drivetrain is almost complete. So what still needs to be assembled is the fiberglass covering and the structural frame that will support that covering. But the guts of the internals are pretty much in, and now we're starting to do some bench testing. So we're spinning up the machine, we're yawing the machine, pitching the machine, and doing some preliminary safety and function testing on the ground in our facility. We're trying to do as much testing as we can on the ground before we put the machine up on a tower. We want to minimize the challenges of fixing a turbine in the air. Here's some more manufacturing photos. The one on the left, you can see we're mounting the gearbox and the main shaft on the bed frame. The image on the right, we're mounting the hub onto the main shaft. Image on the left here, this is one of our employees standing in front of our fiberglass covering. We've got a multi-piece fiberglass covering that'll give it what I think is a pretty aesthetic look. I hope others agree with that. And then on the right, this is a photo from last week. This is the completed foundation for our prototype machine. It's a pretty unique foundation. I can't really go into details of what's underground, but we worked with the foundation designer from utility scale wind to put this design together, and the install went quite quickly. We were able to install this foundation in just a few days, and it's ready for a turbine right now. Our turbine's not ready yet, but this is the foundation that it will be mounted on. A bit about our team. Our team has quite a bit of experience in wind, and I think we're pretty unique in that we pretty much all come from the utility scale wind space. So my background is with Siemens Wind Power. Our head of engineering is from Vestas, and pretty much all of us cut our teeth either in the design, manufacture, or testing of large scale turbines. And I think we learned a lot about how the industry works over those years. And now we're trying to take kind of lessons learned from utility scale wind and scale them down to our smaller 85 kW machine, with the whole goal of minimizing cost of energy from our turbine. And as I mentioned, the machine's not yet ready for sales. We're still in testing stages. We're hoping to deploy our turbine on a tower and do proper field testing this fall. So by the end of the year, we're hoping to have blades spinning, and we'll certainly take some photos and videos and post that online. And if testing goes well, we're hoping to pursue certification testing next year, and in parallel start first commercial projects. We've got a handful of pilot customers lined up in the US, so we'll start deploying those probably second half of next year if all goes well. So my contact information is here, and you know, we're a pretty young, flexible, nimble company, so we're always looking for collaboration or partnerships. So if anyone on the call is interested in what we're doing, please don't hesitate to give me a call or shoot me an email. And it'd be great to connect with more international folks, because right now we're pretty focused on the US, and we'd like to open our doors a little bit and see what's out there internationally. So that's all I got, but happy to answer any questions.
Okay. Thank you very much for the presentation. I think you should try to look back at the presentations of this morning and see the presentation from Otto Reinke, because that's a lot of the things are going in the same direction. So there might be a collaboration coming in there.
Great.
Yes, exactly. So is there any question from the audience? And of course, if you need any testing facility in Europe, yeah, Volker Center is available. Should do some promotion as well.
Thank you.